शेयर करना पड़ता ग्रुप ज्वाइन कर रहा है सामने वाला
वो करो ना करो अपने को लेन देन नहीं कर सकते
रिकॉर्डिंग ऑन तो
फोटो तो मला सेशन चालू करून जायचंय
शेयर ऑटोमॅटिकली होता
मला वाटतं ऑटोमॅटिक नसतं होत
ठीक आहे
म्हणतो
चेक
होत
कर
असतं.
आता लई दिवस झाले आपण
हा ना जुने झालं
टेस्टिंग करेन पाठवायचं
आणि शेअर करायचं का देखील आणि शेअर करायचं का
दिख रहा है
रेकॉर्डिंग झाली का
राहून चालू
त्याला स्पॉटलाइट करणं
सर
Good afternoon, everyone. I hope you had a refreshing break and are ready to dive into the second session of our faculty development program. It is an absolute pleasure to welcome you back for another engaging and enlightening session. The topic for this session is concepts of GIS modeling, a subject that has become increasingly vital in various fields of engineering, planning, and environmental studies. Geographic information system modeling empowers us to analyze spatial data, make informed decisions, and solve real-world problems with precision and efficiency. This session promises to provide us with a deeper understanding of fundamental concepts, tools, and application of GIS modeling. To guide us through this fascinating session, we have with us the highly accomplished expert, Professor Reddy, Keesara. Sir is currently working as head of the department and professor in civil engineering department at the National Institute of Technology, Warangal, with over 20 years of experience in the field of water resource and geospatial system. Sir has carried out research on watershed modeling, climate change impact, real-time forecasting of floods, geospatial applications on water resource systems. He did his postdoctoral research at Texas A&M University on the topic impact of climate change on water resources, with Raman Fellowship given by Government of India under Singh Obama 21st Century Knowledge Initiative 2012 for the year 2013-14. He has carried out total 9 research projects with funding amount of 340.3 lakhs, out of which 3 international research projects and 3 national research projects with funds from DST. Sir has published more than 120 research papers in journals and in national and international conferences in the field of water resource along with geospatial applications in different domains. He had developed RSGIS laboratory with funds of rupees 1.5 crore over the years. Sir has established Center for Advanced Geospatial Solutions, a mini center for excellence in the department. Now, I would like to request Dr. S. V. Lahani, sir, Director in charge, Dean Academics, Deogiri Institute of Engineering and Management Studies, to felicitate, sir. Thank you. Please join me in giving a warm round of applause to welcome Professor Venkata Keesara. Thank you. Over to you, sir.
follow my ये उनको दिए है लगा लेंगे
पता नहीं मैडम ऐसा
क्या हुआ बीच में दिख रही हो इसको ऊपर करना फिर उनका हो सका था
नहीं फिर वो ऊपर जाता है
करेंगे ना उसका एडजस्ट
वो दिखने से
अब उसको कुछ तो भी एडजस्ट नहीं हो रहा है देख करो
Good afternoon.
I think after, thank you very much for introduction, nice introduction, and nice to know that you are alumni, our alumni, Senator Warangal. So thank you. Nice to see you here. And after lunch, it is very difficult time to take you a very hard course subject to teach you, but still I will do my level best. And I will actually I will whatever I am planning here, whatever we did in the last 15 20 years, where with my students, scholars, and myself, we are working at different aspects of this GS models. So in this presentation, I will go through those things. I will explain it briefly. So take that as a point. You can really work with a lot of things. I think your training session is there, so you can a lot of things you can try. And we will one exercise also. Actually, I will pause that one. I think you can ask your who are the QJs we are going to explain you. You can try same thing whatever you are explained here. You can try very simple. You can try that one and then you can see how it is working actually. So GIS models and modeling concepts. So I think most of you are maybe doing the, you can say, I think this, I came to know that a lot of you are all teaching actually different subjects related to the, of course, computer science, maybe the civil engineering. So where you may come across this word model. So what is the model? Of course, here it is there, but can you tell like a different meaning of the model when you build for the any system? What is meant by model? Any of you can tell like of course we are saying a representation of a simple phenomenon. So how we can see this one? How a phenomena where we can represent in terms of model. So in your subjects you can tell one example like where something is we can call as a model. Any of you can tell like something we can call as a model. Yeah, textual data, yes, that is the model. So we are representing a textual data which you are bringing into a graphical format is a model. And so many times your equations you are using right equations to make the some process or you are writing computer programs. So they are all like a one type of model. So you want to represent some process. You want to bring some model into a working is a any phenomena which is there, like for example, any of the civil engineering domain or any other domain where one working mechanism is there, same thing you are representing in a equation or either it is a computer model where we are doing simulation, everything we can call as a model. So we are representing the, you can say one phenomena or one process. So that can be a simple equation also. Equation also we can call as a model. In that equation we can represent the one process or phenomena. Okay. When it comes to GIS, I think morning, I think regular sir maybe given some exposure to you like what is the GIS and fundamental aspects. So where you are using like a one model or means like a map. Map is I think you are come across the different, you can say the maps which are you can see the Google Maps or you maybe see something like our India map, all things. So or we call them as a models actually. They are also models only, like they are like a real world. We see the how the things are there with a graphical abstraction. We are bringing them into the, you can say on the system or computer or in a hard format. It's a model actually. Then there is something called vector and raster model. I think by that time you also got some introduction and then later part of your lab also will come across. Can anybody tell the difference between these two? Since later all our discussion is related to those things only. Vector and raster. What is when we can call as a vector model or something and when we can call as a raster model? Pixel, yes. Means anything like a normally if you are able to represent any real world features, okay, in simply point, line, polygon in a geospatial platform, like you are after this class you maybe see the practicals where we are representing some real world things in a form, lines, points, polygons, that we can call as a vector model. Okay, so anything in the, you can say suppose you have nearby a lot of historical sites are there, historical places are there, right? All things we can represent in that vector model. Then raster model, as mentioned, like it is a pixels. Means what? Everything, whatever the real world is there, everything become a pixel. It's like a this particular thing is very much useful for the when you are representing the, you can say the data in terms of the continuity. There is no gap between the features. Vector means points or lines, gaps will be there. But in the raster, no gaps. So for example, area you want to, Aurangabad you want to represent, everything in form of pixels only. It's like a just example like a satellite image. Is a one model. We are taking that satellite, we can see the image of a area. Okay. You will see how those things really, we are working with those, we can say models, and we will develop some process. All things we will see one by one. So there are so many, you can say models are available. So you don't need to much worry about the theory, but when you are really working with some, for example, some of you are planning for some research work, those things you can see some of these things. So there is a something basic models which you are using in the JS. There come in two things. One is called descriptive and prescriptive. So what are these two descriptive and prescriptive models? Descriptive means, for example, somebody asks like Aurangabad how it is. What you will say? You will say so many things, right? We have so many, that side we have something, this side something like that, and like that you will say, right? It's all like a description. You are doing a description, right? So same thing you put in a JS that become a. So we are all like making those things. You are showing that become a descriptive model. Then what is the prescription? So you know about the prescription means what is the general meaning of prescription? So if you go to doctor, right, you will explain something, then you will write something, right? That is called actually prescriptive models. Means like based on the data is given, we will make some model, some process to explain that thing or what going to come you are explaining. That is called prescriptive model. So once geospatial data, we can make the based on the existing things, we can make one prescriptive model. Like for example, Aurangabad is there. Next 20 years, how it is going to develop. If you explain how things are right now there, we can able to make a model for the next 20 years, like how it is changing, where to really development takes place. Everything we can explain. So those things are all comes under the prescriptive models. Then deterministic and stochastic. So I think stochastic, I think some of you are explaining your subjects, you may come that one. Stochastic. What is by stochastic? Probability means something is not a definite. We are bringing to a model format. Those things are called actually the stochastic models. For example, rainfall, temperature, those things we are predicting the future, right? Normally you can't say exactly, right? If you see in your Google or some weather portals, what they say, 50% probability, 90% probability they will say, right? They will not say 100% like rainfall will come. Means how they will model is like we will make a, I can say stochastic models. We'll make all the options. We'll find out say how much it is going to happen, how much is possible. That type all models comes under the stochastic models. Exactly opposite is deterministic. Something is clear. Whatever is going to come, you are exactly predicting 100%. That is become a deterministic models. Most of the, you can say, our civil engineering sometimes like we have some models, all things, they are deterministic. So we'll hear something there for some process there, just we will give some equation or we will simulate. So there we will not give chance for any probability. Those will come under the deterministic. And the static and dynamic. So anybody first we can tell the dynamic. Dynamic means changes you are predicting. So in a model you are developing. So dynamic model you are making means you are predicting the changes continuously. So they are all normally called simulation models. So it's like a continuous process. Okay, especially the weather forecasting. So climate change studies, like a city, like a urban growth models, they're all comes under this category. Okay, so like now, like you have the machine learning algorithms, right? So many possibilities to develop these dynamic models actually. So you can able to connect actually, and you can make the process how you can say dynamically it is able to understand the data, and it can give all the answers for so many problems we are giving as inputs. Static is like a one time. Say something like for example, you are making a Aurangabad map. You are making and giving one time. That is a static. Okay. And the last one is inductive and deductive. It is also very simple to understand. Inductive means, so here inductive means like a last output, and input, in between there is some parameters will be there. So those things you will identify. So it's like a very some of the, you can say, especially for the computer science, electronics and communication or civil, there we can make this type of things, this type of inductive models. Normally model means what output is we have to simulate, right? But it's a different. Output is known, input is known. Then we have to find out the parameters which influence the things. Sometimes those things are important for us to understand some process or to make a Any difficulty? No, no. Yeah. So similarly, deductive means like so many processes will be there. We are going, we can say one by one, we can connect, and finally we are going to make a one process. So many things will be there connected. So it's like a input to output in between connections. Inductive means input to output is known. We have to find out the parameters. That's where the deductive inductive models will be there. So here, anybody want to, it's like a PhD type of, we can say the problem. It means it's like a development of model means you are developing solving one problem actually. So here, what type of modeling process normally, how the steps will be there. So normally when you want to make a model, so here you can just go next, I will come back here, this thing. So you can see here, right? One, we can say connected things. This is exactly a water resource problem. I think there we will get some more. I think tomorrow some lectures are there and after tomorrow. So they're all like everybody they want people, they will start with like this only. Like what is the, I can say one idea they will take, then model and then get the outputs actually. It's like a one thing. Yeah. So here, so you can see this is the place we will do a lot of work related to the geospatial data. Anything mathematical equation you are taking, right? That mathematical equation will give the final your process output. So you need to make a lot of input for that one. Simple case is like, for example, runoff. For example, anybody asks like for city like Aurangabad, for a one season, how much runoff is going to come at the end of the, you can say the city. So where you want to make a build up a drainage system, or to want to store some water, or you want to make rainwater harvesting, anything like infiltration, anything you want to study, right? So there, once you identify the phenomena, so you are going to select, this is like a what set, anything, study area, that may be city also. And mathematical process you have to identify. Then you want to make anything, this is just one example. It's not need to be like a finite element method, like anything. Nowadays, like a lot of machine learning algorithms are coming. Anything is a model only. So this is the place where all you are right now, you are working, right? QGIS, ArcGIS, all the things you will use. Okay. So your equation, what is required equation? Like a rainfall runoff, I am saying. You tell me I want to estimate runoff. I think some civil engineering student like hydrology may be there, some faculty are teaching. Can you tell me hydrology, like for example, you want to get the runoff. What and all inputs you have to give for the problem? Runoff I want to estimate at one point. Means how much water is going to come. What inputs you have to give? Infiltration. Inflow means that is like a rainfall. Outflow means like runoff. What is it in the infiltration? One phenomenon important. Then slope. Then but the aspect. Yeah. Catchment characteristics means exactly you are saying, right? So their land is land cover and topography. There all comes under that one only. Catchment characteristics. Like you are saying infiltration, right? What is the permeability of the soils and soil characteristics? So all comes under that one. So somebody saying like a topography dam digital elevation model is important. Means like a sloping characteristics. So how much water to come, how it is has to come, everything is like defined. So these are all things. This is the place where you will work a lot of, you can say, geospatial analysis. That's what you are learning in the next, I think, 1 week. You are knowing for some people like where they are, how they will work, and how you can also do with these things actually. So this you will wait remote data is input, right? You can generate this map very easily. So you can make this map on the slope map. So all the things, some of the things you can explore today, if you can discuss with the expert who is teaching. So you can generate, they all become the inputs. Now you know the rainfall, right? You know equation. All the things either you reset like a two models, vector or raster. Each and every pixel you will give input, or every line or point, whatever the drainage you are getting, there you will give input. Then finally at the end of the place where you want to simulate, you will get. That's where your model building takes place. Correct? So it is like a process like a making the data from geospatial thing. On the same model, right, equation, right? Now we will show you after some time. We can make the, previously we can write a computer program, separate it will be there. We can inbuild in the GIS. Something that we can show you after a few slides. Case studies, I will show you like where our students are working actually. We'll show you so we can appreciate at that time. So that will suppose that's what I am saying. This is like a same thing, like a 4 steps. We need to make the goals, make it into parts, then do the calibration. calibration means like any model, if I am saying working, what you will do normally? Directly we will, one equation we will give the input and you will get output. That we can say as a correct. There is so many parameters will be there, right? So that parameters has to be correct, then only we can able to simulate, right? So for that, what we need is, normally I think most of the people who are working in this modeling, they will now come to know that you need to know something called observed data, some observed phenomena. So that what you can do is that will keep as a database. You apply the input, observed data is already there. So you can able to check whether whatever the equation you are provided, parameters you are provided, so it is correctly simulating or not. You will verify. And accordingly, we will go on change parameter till you will get a expected data which is close to observed output. So in this case, for example, rainfall runoff, case runoff, you may measure with the gauge station. So same thing you can compare whatever you are simulating and whatever it is there is coming correct or not. Not coming correct means you need to adjust the parameters. That's all. That is the important step. So unless you could not able to make this one, your model, somebody later you are giving like a very big models you are studying in the next few days, like somebody say like a HMS. You are building, right? So you are building that model means how you can say that is a correct output you are getting. So you need to adjust the parameters and you need to study the output how you are getting. So then validation means calibration, you take some output, adjust the parameters, and you check some more data for the validation. Means that is also observed data only. So in this you can't change any parameters since you fixed it at the calibration, right? You that only will check whether they are really making a sense or not. Okay. So normally the rule is like a 2/3, 1/3. Means 2/3 of data you use for calibration, 1/3 for validation. Then your model is ready so that you can work and you can give for others. Okay. So you can this is the thing. This is the one of the I can say watersheds where after making the equation, so much background input is there, so that no need to worry about that much that right now at this point, but you can appreciate the how really we can make a simulation. So same thing, for example, in QGIS now, at the time when we are working with for K3 problem, we are doing this one. Now we can do even animation also. It will come animation and you can see the present these things. So here actually 10 minutes, you see that this is like a one watershed, it's like an open book type of watershed. Open book means both sides water will come. In the middle, water will flow to the one outlet. You can see here, right? There's one color 10 minutes. These values you are seeing, right? And it is 30 minutes. You are seeing, right? More values are increasing. These values, high and low. So then, after you can say that 60 minutes, what happened is the values are reducing, right? Here means what? Here you see this blue color where the values are very low values, and then they are concentrating here, right? Means what? Will tell that the water is rainfall is stopped. Rainfall stopped means water will not be there, right, in the this thing. So it is like a clearing all the areas and finally focusing at the center. All water is coming to center. Then finally you see there is a all thing is like this blue color, right? And there is a one central line you are seeing, right? That is the place where the water is flowing finally. This is happening at T is called 100 minutes. Same thing we can see the simulation also. So what it will tell, like you can make a one model. What I am saying, right? With your equations or whatever this thing, you can able to simulate like this. With what it will tell, for example, some flood is coming. Each and every time you can see at each and every minute what is going to happen on the area. This normally is not possible in a conventional system, right? Where we can't one equation input output will be there. You can't appreciate. But GIS you can appreciate this one. You can simulate also. Now, if you are some of you are experiencing like a ArcGIS working, then there is some time simulator is there. Time means you can provide time also. Each 10 minutes input you are giving, you can see the simulation. So that type of things is possible with this JS. So we tried and then this is the thing. So just I kept each and every input and then output which is coming. So we can see same as the in the model also. This is the model output only. This is the like a where we are you can say doing this. You see, this is the finally the I think who are in the once again hydrology, they can know what are these things. What are these things? What is this one? This graph in hydrology, what do they call actually? Anyway, civil engineering are there, right? Civil engineering. What is this one? Hydrograph. Okay. So I think this area, I think this is from this area only. This no Karakohal. It's near to Nashik actually. So this is one of the watershed when I am doing PhD work actually here. This one, Kadakohal is near to Nashik. So there we made all these drainages like this into this one. This is like a model. This is what I am saying. All process. So the real is the real. This is the you see the background blue color, right? That is the real. How the really the area look like. But that we can't exactly bring into computer, right? So what you have to do is we have to make them into grids. See, we are making into grids, and then this all the these are all like a boxes, right? So they are all like a connected through equations. That's what is exactly model. And then we can simulate, right? So you see this color, right? Observed. And this is simulated. This is what I am saying. Is a rainfall. This is the way the simulation is taking place. So what it will tell to you? This is the like observed, right? And what you are simulating is coming close, right? So whatever this is coming from equation model, JS model. Whatever you see is this one is observed data. There's observed gas station is there. So there is a measurements are there. So those things we are all like taking that thing and then you are simulating. So we are seeing closely coming the data. But in this case, you see, there is a lot of gap in there, right? Means what it will tell? Your model it is not able to predict. It is not able to bring close to the what really happening in the field. Means we need to adjust some parameters of those things. Actually, it's like a validation case. That is observed case, other case. So like this, you can make you can see this really the way the model will come into picture. We can do the simulations. Okay. Same thing like tomorrow, next few hours, means next 2 days, what we're learning, like 5 days, right? So SWAT model, HMS, so HECROS, where you can see those all things, they are of this nature only. But at that time, our case, like we develop our own model actually, for intermittent model for this simulation. So here, when making models, right? Model means JS only make some things, but a lot of things will be like a JS will help. For example, your computer science thing, you are doing something like a root analysis or root simulation you are doing, or something else you are doing. A lot of inputs required, right? Where you can use your QGIS or ArcGIS to develop those inputs. That is the first place is the calling as the, so it's like a database management role. So preparing the inputs and showing the outputs. Whatever I showed you, right, previously, they are JS generated outputs. Okay, so you can build the models up. This is I am going to show you like in these things where for some examples for you. Then we can integrate the models and then become like you make some complete GIS based model. Best example is HMS, which you are learning like HMS, right? So that is HMS is of this nature. It's completely in the JS where you can download and then you can work with that model. Okay, so you can see here how this will be done. So here this is like a loose coupling means what? Coupling means what? So coupling means like the meaning like a JS is there, model is there. Sometimes we are doing in a JS, you are doing some input that you are taking and making it to the other model, which is computer or mechanical something, that is called loose coupling. So in JS software only you are doing this computer related to all the things, anything is related to any subject, but become a type. So embedded means there is no difference. If I am doing QGIS, right, we can able to work with that one. We can generate anything for some particular process. That is a type of embedded system. So whatever you are running like a QSWAT, somebody asked me like a QSWAT, right? QSWAT is a embedded model. In the QGIS, they embedded the SWAT model, so you can work with that one. So you can see some of these things. So you can normally, I think very easily you can work with these models so many times, either in the computer science or ECE or in the other different subjects, they will come into picture. Where you need a spatial data, this you can see for GIS. So one thing I will show you, I will come back to you, this one. So I think you are seeing this layers, right? Means any of you like already have some experience in already GIS so many layers, you generate all things. You have any of you can tell like you have some GIS layers you prepared. Anybody there? So you are, I think you have developed some of the layers. Buffer zone. Okay, contaminated area. Buffer zones. Okay. So any other persons, like any other already have some step of, you could able to see. So this is exactly what you are doing in the digitization. Like today, the QJS, this is one type of phenomena. Like you see 1, 2, 3 means like there are one phenomena. And this one is a second type of, we can say this one. And you are combining those things. This is one thing, right? This is one thing, right? So this you are combining both things, you are getting one output. That is called binary model. For example, you want to know, find out something like a, you take the city, best example is like you take the Aurangabad city. So you want to know like a, how the infiltration is taking place, areas which are more. Means what you require, how the infiltration will be find out. What is the criteria for infiltration? What you require infiltration layer to find out means I want to know how much infiltration is taking place in Aurangabad, means like how really groundwater is improving. We need to know some soil layer, right? Soil types. Some we can say black cotton soils, red soils, their different characteristics will be there. One may have more permeability will be there, one may be less. Similarly, people are all like a paving, right? Paving means like a make all the roads like a without any permeability. And similarly, they make a road blocks or side roads, everything, and then make everything impermeable, right? That is like a human, like a soil is a natural thing, right? The soil layer. Then on the top of that, some people are making a lot of, we can say the layer that is called like a human developed, we can say layers, maybe like a road construction or pavement construction or building construction. They're making impermeable surface, right? So now somebody asked like, this layer is there, or already soil will not allow, some soils will not allow the water to go. Now you want to make one binary model. Binary means what? Binary means true or false, right? Binary means true. True or false means either the only two things will be there when the final your simulation over. So you say something is true, those things will be highlighted. False means those things will not be shown. Now I said right, there is two conditions. For example, people ask like where the more water will infiltrate. Means there should be some places where the lot of gaps will be there. People are not constructed anything. And other is soil will allow. Means what? So both are true, then your infiltration will take place. So that's exactly this binary model will do. In JS, we can do very easily. So whole city within few hours, right? We can generate a model. The two layers are there. So where we can possibility of more water can infiltrate. So there, this municipality government is there, right? There they can able to construct the infiltration pits, all the things. So you can make a model like you see the both are true. That's only case, right? Remaining all zeros. Then you can make a place. You see this model, right? So here the condition is this one and means right? It has to be like a most of about sets. And mean and R. A set is there and B set is there. So they both has to be there means we have to use R, right? Only common things means we'll use and in the mathematics section. That's what is the thing. Same thing in JS here also. So both are satisfying, that will be highlighted. In this case, so this is the two criteria satisfying this model, binary model that is. So very easily you can make the binary models in the JS. And you take any particular phenomena you can take and you can generate these models. Then there is one model called index models. It is also like a very much useful for the, you can say, people actually. So many things you can develop with this index model. So for example, like a groundwater quality or groundwater quantity or something called pollution. Any area, for example, you are taking a very big area and you are studying. So normally groundwater quality, those things like a year infiltration means you can say one yes or no. But quality means what people will ask how that terminology will be there. So in the groundwater quality, if I am using some terminology, means like I want to tell that in a particular area how groundwater quality is. What type of terminology I will use? Terminology means like for example, one area, like say you take the best example like Aurangabad, you take areas, you are taking some samples. You want to analyze, you tell finally the, you can say about this area is like how that groundwater quality is there, how you can classify. Contaminated. So like that, what is the zones? How you can classify the thing? Whether you can there's something like that, highly contaminated, moderately contaminated, like a less, and then beyond the you can say use or better. Like that you will classify, right? Means what? So one area you can able to give multiple answers. So there the question of index model will come into picture. Index model. So means what? You will take a number of multiple layers. So groundwater quality means what are the parameters which will influence the groundwater quality? Chemical properties means like a chemicals, or you can say the industries or like agriculture things which are happening in a place. Then what else will influence the quality of the groundwater? Location wise, like maybe like some soil, or you can say what is already soil or rock properties will be there, right? They will also influence, right? Then geological formations, how they are there, those things will be there. And infiltration properties, like how much water is available, like that we can make a like rainfall. So like these are all like a number of layers. So GIS means the best, what is the main thing you have to, anybody says you have to, whatever to understand is, we can make any area, any place, whatever is the number of, we can say the phenomena are there, that many number of layers we can prepare, layers. That many layers we can prepare. And in the index model, right, whatever is the each layer, you give some importance. For example, water quality, one layer is important, very important. That particular thing you will take as a weightage, more weightage. So other parameter is less importance, means you give less weightage. Like that, each and every layer has some importance. So once again, each layer also, you don't worry about much about these equations. I'm just generalizing and I'm telling so that it's easy for you to follow actually. Then each layer also have the thing. For example, you take only soil. So soil, we have different type of soils will be there, right? Each soil will influence differently the quality, right? You will give there is something called like scale. Scale means like a 1 to 10 or 1 to 20 or 1 to 50 like that. In that, you will give one range for each and every, we can say the parameter. For example, groundwater quality by the black water soils. We give some scale of 5, 7, 10 like that. So what I want to say here, so each layer you will give some weightages, and each in that layer also you will give each weightage for the different properties. So you combinedly make an index model. So like this. So if they are different, you can say this thing. I am saying right weights for each layer. Then each layer we have different properties. So you will combinedly put together. You will make this index map. Means what? For example, so you are superimposing this one, just like you take this is a paper. What is a paper? You keep together. What you will get actually, there is like a layers and a transparent sheets are there, for example, you think like that, and keeping one over the other. So what you will get at each and every point, but then I will put in this way. So for example, S1 is there, right? I am bringing this one, you will get A1, right? And then E1. So S1 plus A1 plus E1 means property, you are aggregate. And here S1 into this weightage, S1 into WS, WA into A1, W into E1. Means some has more influencing, some has less, right? So then like that, so this I1 means cumulative influence of all these things along with their weights. Now you will get a lot of different values, right? Then you will classify. Then you will get this type of layer. This is called index model. So many things you can explain. For example, you want to know something like a landslides occurring in an area. You want to classify them. Which area is prone to landslides? Which area prone to droughts? This is like a drought. You want to explain, right? For example, this whole area. Which area is more prone to drought? Less prone to drought. So where the more groundwater is there, less groundwater is there, more contamination is there. Everything we can explain with this index models. Okay, so many examples, so many you can say the case studies are available if you are really. I think in the one of the sessions we have the paper reading session there, right? Morning, I think that is I saw that thing. Now you can see some of those things actually. The article reading and understanding of things. That you can take some of the examples where really some index models they are using in the literature to understand some phenomena. This is same thing. This is like an example for the vector model. Same thing we can do for the raster also. So now onwards, what is the main understanding is vector means you are working with a lines, points, polygons. Raster means everything is pixels only. So pixels means like everything is like a values only. Every pixel has one value, right? As for a computer science, you will come to know when we see the pixels. Everything is assigned by some value. So those things if you combine, you see here multiplying with the weights and adding those things. So 0.12 into 0.6 plus this one plus you get this final value. So this will tell you the each and every pixel what is the phenomenon. So you see so many phenomena, right? Weather, climate, we can say geological or even environmental related aspects. So many things we can try with this type of models. Okay. So here there is like a more deep models are there, like a regression model, where you can have a multiple parameters are there. These are all called influential parameters, and this is like a where we want to output. That we can make regression models. And this is the one interesting model, like a process model. Means it's also very simple. Very easily you can do in the JS. You know some cell layers. You can say there you are generating. These examples I will show you. So some of our students actually tried this one. So any area, how much soil erosion takes place. For example, this area also like very much prone to soil erosion. This you can say the region, Marathwada region they are calling, right? So one is drought is one of the important parameter, and then soil erosion. So those are all things we can able to simulate. We can show one example. You will get exactly what I am saying. So it is like a simple multiplicative thing. So each phenomenon you will get one value at each pixel. You multiply all the things, you will get one pixel. What is the value? Accordingly, you can tell something is big or more or less. Everything you can tell. You can see here. So now today, as I said, after this class, we are going this thing, right? You can ask, you can say to show this one. You see, you are opening only today QJS, right? There is a toolbox in there. All the things, whatever I am saying, that everything you can do. You can develop a model very easily. So some of the examples are there actually here. Model builder is there. One thing is your duty is first to make the layers in the JS. Then model builder is there, one toolbox. You go there, you try to do two things. One is like a layer making, and second is like a model building. First you make the all layers, required layers, and then build a flowchart for the model. You draw those things. Then try to implement in the JS, the model, so that we will get those things. Like one example, it is given in the incident, it's taken actually. So here, same thing like a today you are doing in the QGIS, right? QGIS, if you go here, you can get this graphical model, you can say modeler. So you can get this one. So this is like a place where all the things are available for you. Okay. So JS layer building is like a bold, very bold, like suppose 10 years back the people are doing. But now JS means you can build the models. That is the level right now. So people there you need to work on those things. Really, somebody interested means either you want to guide some students also, like you want to try. This is the best place. You can ask them to directly work with the models. Data nowadays available. Morning I am saying, right? There is one place called Bonegi. All Indian data sets, everything is available. To download those data sets, click for your area and develop models. Then you get a lot of publications and research. You can do a lot of things. You can do on some problems, project, those things also we can develop with these things. So now just like I will more not explain, just like I will go through the slides, like you will get the feel of those things, how we can develop this type of models. Take examples, like a live, we did the examples. So there are these things are all available in the public domain also, like a lot of papers also there. They're available in public domain. With our student works, you can see. So here is the soil erosion, and then now there is like one of the important problem in the any region actually. Soil erosion means like for a time soil, like especially the soil which is like very fertile and it's very important for the agriculture. It will go on lose or it will be lost because of the various reasons, weather reasons or any other parameters or human induced problems. But here the question is like how we can able to estimate that how much is going from particular place. So here you can see the just now I showed like one multiplicative model. I showed like R into K into like that. These things, they are simple equations. You don't much worry about these equations. Only one thing I will tell you that you can dotting you can see. This is like a one. You see, right? How many parameters are there? How many parameters? Five. So if we could able to make those 5 parameters as 5 layers and multiply, simply we'll get at any place. You suppose I'm standing on this tile. The tile, how much erosion may takes place in the ground, really I'm there, I can able to find out. You're getting that, that's where you can make. So like all, for example, one area, some 100 tiles are there. Each tile, you know how much is going erode, means it will lost over time. That into 100 you multiply means you get a whole area how much soil will go. So soil erosion, where it will go actually soil after eroding, after erosion takes place. This you don't know, right? I think general this thing. I think you are no, I think erosion, most of you, even though from different specializations. Means soil will go from a field, agricultural lands. After erosion, where it will go? What is it?
To the river in case of the dam or pond.
River or pond. So why we have to understand this erosion actually? So you are saying river right means everything will go to river right. What will happen if everything goes to river or dam?
Flood will up.
Flood will come. So if you say dam right, dam will be constructed. All soil is going over there and then settling here. Then what will happen?
Capacity will reduce.
That's the thing. Means what? Why we have this question like a problem making? I am saying like why we have to study this? Means any area, how much erosion takes place. Accordingly, the life of dam we can estimate. So much erosion is taking place. If you did, they are not able to prevent, then it may everything goes to dam or river. It will create a problem there. It may like for example, pond means everything will over a time. Sometimes you will not see the more water. Only it will become a you can say water. Very less amount of water will be there. Depth will not be there. Aquatic fish may not survive. Those type of all problems will come. That phenomena is called as a eutrophication. I think any of you maybe civil engineering, they will come back to that word eutrophication. It is a natural, anywhere it will occur. But if you are not following the thing, it will occur. That is called like a accelerated process. So those phenomena we can study in the GIS. So that is all equations. No, don't worry about these equations. Just we will go straight away to the problem. So anybody, this is like a model, like a one thing is developed in the GIS only. So making the different layer, these are different layers influencing thing. You see all these parameters influencing the soil erosion. Each parameter, like one is related to the slope, and here one is related to the I can say agricultural thing, one is related to the soil, like that one is related to rainfall. So any erosion takes place means soil will has to go from the place, right? So because of slope it will go right. Slope is there, like a water is coming, it will go right. Something is very loose soil is there, sandy soil, it will go first, right? Like we have here 5 types of, you can say the parameters which are there, which are all will give you about the erosion if you combine. And if you take these parameters, we get the sediment yield. How much is going to come at the outlet? It is how much is removing at each place. The two things actually. Okay, so you will see. So if you are know this thing, right, then you can know where to really construct some like a growing the vegetation, like a grass, constructing some small check dams. So all things you can try. Once you know about this one, that is the place. This is useful actually. Otherwise, one to one you can't go right. Very big area. How we can really physically go and see how things are happening. If you make a map, means we can appreciate. Now once you can see this is like one area, our area where our student worked actually this particular place. So these are the different layers used developed in the particular study. So here, each one, for example, you want to know what is the organic matter content in the soil. That will tell about like whether. So organic matter content in the soil, what it will do? It will hold the soil. But it less means water, soil easily can detach and it will go into the river or you can say streams. So that's what we can learn here. So they will tell about the organic content. You see low is there, some places, high, those all names we can categorize. So similarly, permeability, all these parameters, you see the how the drainages and all these are things are the water bodies. And you can see here the contour map, like it will tell about how really we can do that contours. Means that this will give out the topography, slope, all those parameters we can get by contours. So this is like a depth. So by seeing this thing, can easily we can tell right from the water if it is falling on a one particular place as a rainfall, where the water will go in this particular diagram. Can anyone tell? We are seeing right, you see this one, you see this one, and you see this one, and tell like a water suppose falling somewhere here or here or here. Where it will go? Which direction it will go?
Blue color.
Red to
Blue.
That's all you see. Very simple. That's why you see. Everybody can tell. That's where our JS. Otherwise, by looking, we can't say right. Now, the whole area, you see that area we didn't go right. Even we are seeing from JS only. This is a model. From here itself, we could able to say where the water is flowing. And you see the whole water which is from this side, it will go to this side finally reach here. That's clearly it is very clear, right? Then these are the high elevation area. This is a low elevation. And it's like a flat areas. This is all we will come to know. Okay, this is one thing. You see? So here you see the soil map we are preparing. This is one vector map you see. Fine soils, medium soils, and all these things, right? So they will tell you about what type of soil is prone to erosion or not. Okay? Fine means it's very easy to erode. Medium means it is like strong, like that. It is like a, this is also will tell about the, for you see this map, right? This one it will tell like a previously you saw one map. Now what is this one? Where the like really we are saying water one direction, but it exactly it will tell like a line it will make. For example, one rainfall is occurring in this particular place. Finally reach to the outlet, right? Where it will go also it will tell. So the water drop finally how when it will go to the outlet, right? We can track. It's like a tracking. For example, one raindrop is occurred here and it takes some soil. You see, it is kept all the things all the way and then finally go to here and it reaches here. Track we can make and then we can for here. And different colors will tell that like a flow accumulation. Here the color is going to change. Right? Accumulation means water. More thick color is there means more water is coming there. For example, you see here and come to here and compare to here. For example, I am keeping one. You see the dot right here. What is the meaning of dot? The dot. So I am standing on the dot means what it will tell. That much amount of water is coming there. That much amount of soil will can come there. That is exactly what it will tell in the this one. If you are standing on this one, nothing is coming. This is not a drainage area. So you see there is a difference. For example, when you go to the constructing a culverts, you know about culverts, right? Sometimes you see the one they will construct after immediately next monsoon is over. After end of the monsoon, the culvert normally will damage. What is the normal probable reasons? So they are not much worried about this thing only. Suppose you are constructing here, so means this much water is coming. That people, unless otherwise you see this one, you can't able to tell. Like you stand on this one, nothing is coming. Just like water will not. How much amount of rainfall comes, it will not come. But you stand here, this particular place here, this one you see on the top of the hills, everything it will come here. If you are not able to follow the design standards, that will fail. That much water is coming at one go in a rainfall time. So this will that type of so many things we can get from this map. Okay. So here LULC means land is land cover, like we can classify this one, like which is the vegetation, all things. Okay. And it's like you can make the dividing into small watersheds. Watershed is like a one big area, like all the water where it will go outlet. That's a big watershed. You say like a Godavari, you say what is that Godavari will call normally? Godavari basin. Basin means what? It's very big. All small watersheds will finally flow into Godavari. If I say small like a basin like a Penganga means like a one big small catchment it is called. So means some amount of water will collect and add to the Godavari. It's like that. So it's like how the rainfall is going. These are all some mathematical terms. No need to worry about this one. These are all like other phenomena, same thing. So these all slides are shared. Somebody interested means they can use later for their university students or their purpose. You can use these things. So here we can generate a factor like a, this is like a crop, like a how crops are there. So you see when the erosion takes place, right? Everything is vegetation means when the erosion takes place. Can never tell like you are completely covered with vegetation. When erosion takes place, it's like a rainfall occurs, right? It's a lot of energy there. So you are covering with like a one cushion vegetation. Soil is down, so it will take all the energy, so it will not go and dissipate. Same thing, you remove the soil cover means it will, I'm sorry, vegetation cover, then it will more impact on the soil. So like when seeing the crops, you see some crops are called row crops. Row crops, you know, right? We have to keep like a cotton, you know, right? Cotton or mirchi, or to keep in a rows. Same thing like a something like a what you can groundnut, or you can say some other crops, right? It's like a cover crops. You put this, it will cover entire thing. We can't see even soil also. That kind of things you keep means it will take care about the soil. It will not allow the soil to erode. Depending on that, we can classify. So, like a similarly slope of it, like a very high hilly areas are there, more prone to erosion. So plain areas, less erosion. So those all things will the factors. This all like this we can make a map of like how it's really influencing. So here this is like a cover. That's what I am saying here. C factor map. So this is like a conservation, like a, whether you are taking care about the watershed or not. Means you are doing the when you are doing agriculture, you are following some practices which will take care about the erosion or not. If you are not following means that more erosion will be there. So if you do all these things, you see, after combining, that's what I am telling. You are 7 parameters you are generating, right? Each parameter some value will be there, right? You multiply all the things. That's all. Some numbers only, they are like numbers. Like a 10 into 50 into 20 into 30, like that. So you multiply means each value will be like this, right? So you see, for example, this color region, blue color region, right? So there is like a, so many factors are multiplied, finally it is giving a some high value. Means what? That particular area is more prone to soil erosion. So in the whole area, you can now focus on that areas. You go there, see that something is wrong. So see that how the agriculture is happening or any other issues. You can work on the things. So less areas, don't need to much worry about those things. So you see one single map. So for if you give to English space, they can able to solve so many things they can able to address. So this is the way this type of models very easily you can do for the in the GIS. And one thing is, for example, you did for the Aurangabad, for example, some area, one watershed. Can we not do for some other district? Yes or no? One area, one model you are developing for this region, you can't able to transfer to other region. You can easily transfer, same GIS model only, right? That's where the modeling comes into picture. Means you can replicate. So one you are able to, one time you are able to generate the toolbox. That's all, like your own toolbox there, right? Anywhere you can apply. Any number of times you can try and then you can do the answer. Okay. There's a question here. Yeah. Yes.
One layer is very important for me, so I will give 10 points for that. Out
Yes.
of 100. Some layer is having points. So how we can decide it, whether it is important or not? Is whether I should give 2 points or 8 points or 8 points out of 100. So that how I should, because whether we change the priority of this layer, the result will be different.
Yes.
So what should we do on that stage?
Yeah, that is a very good question. Actually, it's like so many fields, like what you are saying, like it will come in agriculture, it will come in the, you can say the similar geophysical studies, and so many fields. So that particular thing, how to actually address it, that is called as a expert, you can say the analysis or expert opinion. So what you will do, right? For example, you feel that some layer, some say like a soil layer only. Soil layer, like you have 4 soils is there. So how to give each layer some value? That's exactly good question. So what you will do is like there is like some people are so many people will be already experts in that thing. Like they have number of times they studied different regions they studied. What you will do, there is called a questionnaire. So questionnaires, this is called actually also called technically called Delphi procedure. Delphi, DELPHI. So what this Delphi procedure says? So any layer you want to tell like how each one is important. So you will take some 100 people opinion. Somebody, okay, this particular one area you are providing like these layers, sir. So you see like 4 parameters are there, right? So you will ask like you tell me I am giving 1 to 10 scale, which one is a more important? Somebody like already 10 years in the is gone to the field and you know every soil like that. Okay, you will say that easily. He or she will tell that okay, this you give 10 points, this only give 5 points, this only give 6, they will tell. Some other person is there, right? So means you will take some expert's opinion and combine those things and you will come to a one scale. So all those opinions, for example, you survey to 100 people. 100 people, they will give opinion, right? So that you can either average out or you can take some scaling you will do and you will arrive at one values. Okay, since that's a very good question is why means some we can't able to, they are not like some practical you can measure those things. They are like all good, bad, and then scale how you can give. They are all like experience people can tell like over time how things are happening. That procedure you can make accordingly, you can scale each layer. Now you got that one. Yeah, that's what I'm telling. First of all, you see, you are some soil erosion taking place, and then we said like river, there is a lot of soil sediment is coming, right? You have some measurements will be there at the outlet, right? Something is there with you. And now previously nothing is there with you, right? You got expert, something is there with you, right? Now what you can do? Build the model, you are there right now, you are not satisfied with the expert opinion. Now what you will do? Outlet you have some values are there. We can go on change the expert values. Now no need to go for the random, right? Now it's not randomized, right? Within that limit, it may like a somebody say after 100 experiences, somebody said like a plus 5 is there. Now you try plus or minus 1 or 2, you try. You may fix up at 4.5, 3.2 like that. That will become the thing, it will be model, right? That's why we can try. So at least nothing is there. We see here basically important thing is I have a very important point what you are raised. That is a very valid question. You see, for example, if I am saying here hi, this one. So the question here is no need to worry about much about the value 1271. No problem. What is there? It's 100 also. It's like a instead of 100, it's 1000 also no problem. What it tell to me? There is some issue there. We need to go there and address. That issue is high. That is simply say okay. Means these are all like a process models, right? You can't exactly go for the exact value. It's a civil engineering type of open-ended problems, right? No problem. That we can definitely do it this way. First to make a model with expert opinion, you can go on improve with the collective, we can say wisdom or collective data and through validation.
Same problem. Yeah, I just want for the best location for something. I'm not saying that this is what I have used for.
Okay, yeah.
But that area is already constructed by some bridges or roads. So
Yeah.
it is not possible to break down this set of roads. So
Yes.
it may be very costly. So best area we are switching to the another location because of these roads. So,
Yeah.
but in my model, I have given less weightage for that road map.
Yeah.
So that thing is happening in my model. So that's a response.
Yeah, that's it. That's what I'm telling. So it's like a whatever you are giving and whatever was filled with lot of yes, definitely those type of things will come. Yeah. Yeah. So finally the sediment yield. Like a sediment yield means like a how much is coming at the you can say the outlet. Erosion means how much is detaching from the place. Yield means how much can go to accumulate to each place. So yield means like we can able to measure exactly like you can use some instruments, all things. For example, just now saying like dams. There is a lot of I think instruments. You visited there. I think Valmi you are going. Valmi I think when I going I think you can see there is some samplers collecting those things will be there again. You can check actually. You can ask there is some instrument where really make a flow measurements. At the same time, they will also measure about the sediment yield how much is going to come sediment. Okay. So this is the thing. This is like a one case study. Like we can work with the soils, right? Same thing we made like a climate, we can say the thing, right? Each area, like a, for example, some area you want to say it is a drought. Some area we want to say like a high temperature going to come. Some heat waves are going to come. Rainfall going to occur more. Less rainfall for those things. We need to estimate, right? So nowadays, like you have, you can say, especially who are working in water source area, those people they may know about. There is so much data which is available about the climate. Okay, so if you go to IMD, any of you check the IMD website, Indian Meteorological Department website. There is a 100-year data is there actually. 100-year data like for whole India. There are like a grid values. Grid means each grid like the whole India they divide into grids. So each grid is like a value of like a 0.25 by 0.5 degree. Okay, so that data is there with you. Now with that data, suppose I want like you see that is they are given for whole India, right? But I am only want to work on Aurangabad, how it is going to study, how it is going to impact the climate or which is coming for next 10 years or 20 years. So there is further no data, no need of all India data, right? we need to take out only the required, you can say data from hundreds of data sets. So for that, what we can do? So every time, for example, I am doing today like some small thing and I am giving. Tomorrow somebody will come. Once again, I am doing in the QJS and I am giving. It will not have like you are not really optimizing, right, resources. What you do is we can make one model. That model you can apply anywhere you want, like any basin, anything, any study area, you can able to get the grid points. So you know that 5 grid points are falling in the particular study area. Those data only download, no need of other data sets. That type of model we developed actually with this modeling mechanism. We can see that one actually. So this is like a one easily we can make in this ArcGIS, like there is a toolbox in there. So this is the where you can see we can give the one bounding box values. Bounding box means the latitude longitude there. I think all of you know about lat longitudes. GIS, they are the fundamental thing. So the GIS map, you see at the down right, there is one corner where we can see that one box where we can see this lat longitudes. So here you can give this one, and this is the file is called climate file. They will give for whole India. So from the file you give as input and you give this one, it will give you something. So finally you want only these things. I think this each one you know, right? That is like a one lat to long, means 1 point, which are of interest for you. So you can see here, I am saying model, right? This is the model. So we need to background in the QJS or ArcGIS, we can make this thing. So each one, what is the thing to give next level, what it will go, like this, it is like a steps, what layer you have to give, and then what it will finally go, and where you are giving, what you are providing the time, and finally the output is grid points. Means what you will one study area is there, for example, some Aurangabad, I will only give 2 things. One I will give the climate grid point layer, and one I will give, and I will give the boundary of the Aurangabad. That's all. So depth means visualization model of the Aurangabad. Then it will automatically tell the what are the grid points which falling in the Aurangabad. Why you have to know that one? So that point data only you will use to analysis for the rainfall or temperature. No need to study everything. That's what is the thing it actually you can see here. You see, this is the one small area. Once again, this region only. This Varda, you know it, Varda, the basin actually. So there's a lot of studies actually on NIT Warangal we are doing about the Varda basin. So where how the climate is influencing, how climate change is changing the runoff there, all the things. You see, these are all you are seeing right, all these points systematically arranged. They are within the boundary, right? There are the climate points. Now I will only study these points out of hundreds and thousands for whole India. I will take this point data and then I will study and analyze. I will make a spatial maps. So this tool we are giving, right? Anybody can with the tool they can able to make these points and then you can download. This is like the Warangal region where so even some outer points also it is falling. These are all the climate points. If you want to from you are seeing only here is 6, 7, right? This whole thing is covering. Whole India things they are covering. That we are picking up the few things only. You can't simply by drag and drop. You can't. Once model we generate means we can easily run and then we can get those points. Okay. So this is the points climate points like these things. These are all like you see the points which are those from different models. So this is once again, of course, this is different altogether different subject. Like a climate grid point means like so many models will tell about the what is the climate of an area. So with that any model thing we can able to make it for the study area. Okay. So same thing like now we are only making the I can say getting the data right. So you can do something like this actually. You can just to see the things. So this is like a model once again. So giving all things up, and it is interesting like a different thing, like not only getting previously only getting right, we can do differently, we can see differently. You see here right now. This is the model like where I am doing postdoc, we develop thinking later my scholars pick up that work and they further work on this one. So here this is all like a once again model developed in the with the help of the QJS. There is one programming language. I think some of you are from computer science background, right? This is right. So R programming, you know, R programming. R programming, it is developed with this R programming, very easy. And Python, if you know Python, this thing, Python you are using. Okay. MATLAB also you can do. So that is like a MATLAB is like a closed one. Python are like open, means like a lot of things we can do with ArcGIS, QGIS. Everywhere we can apply the tools and we can make this type of toolbox separately also. Okay. There's some tools are there. So like this, we can make the tools, all these models. There is a like this tools, all these things are like each one we can get with the programming language, R programming, and then all the things will go into the, you can say all these things are like various, each one is a model actually. So previously I was showing red one. So here you see, this is like a one, we are giving the all those rat computers and then all those things. So you can see something like this actually. You see, so previously what you are seeing, only grid point, right? Now what you are seeing, you see precipitation, like you see, like now you can tell, right, where the more precipitation is there and where less precipitation is there. Okay, that's what is the, you can say the modeling we can do. We can do all things, we can connect and then you can try. So even everybody can, like any of you can also try one particular thing you can take and you can work actually. One. And you can see that, so you see, like normally when a month, you how many is here, how many months will be there? 12 months, right? So now press one, right? You can see at one go with one click actually, we can see in 12 months how this distribution of rainfall is there. Rainfall per mm per day over the each month. It will tell so many things, right? These are all things we can make and then you can work. Just we can see the, like a lot of, like what are the things that there, right? These are all things we can lot of literature is there, and then our papers are there. I said like it's like a open, like if you my name or those things, our NIT Warangal, like a civil engineering department. If you go visit our names, everybody's these works are there, like all located those things. You can get most of the things are available in open source. Like you can easily download this with one click, you can download. Yeah, for this thing actually the main about the fundamental making the, you can see the models and how to make and how to use, how to apply for solving some problems actually. Okay, so I think what we can what is the plan is like you can take it like a small break and then secondary thing you can make. What is up to 4:30, right? We can give a 5 minutes break. So just like you are getting one concept like a major thing. So later some hydrological modeling, for example, this is a general thing, right? Hydrological modeling, you will see only some specific case. I will show you some slides. Is that okay? So we'll take a break for 5 minutes. So that it will be, will relax, otherwise it will become, so it is very difficult actually to follow so many things. Yeah. Anybody doubt any questions you can ask actually? Yes. Yes, yes. Yeah. Fine. Any questions you can ask, otherwise you can take 5 minutes break and then we can. One area how you can create the yeah, oh yeah, that's a good question actually. That is actually Excel based, right? That is actually we developed one model that is called actually the, it's like our own like runoff model. So where right each box is a different. So that's it's like a parametric models in the parametric model is right. So even though it is looking like a this strip, it's a strip. So strip means like a one area is like a bigger trapezium, small trapezium, right? But what is the assumption is? So that area is like that length is right, width is there, right? Width on both two sides average width. But length and breadth. Then what it will become? So even though that is for us is there, exactly what trapezium shape, right? For us, when model knows length into average width. So that we can make that as a. Otherwise, we can't simulate, right?
I just want to learn whether it is available for this.
Yeah,
I just.
yeah, that's where we done actually. Like there is an Nashik video and 3 washes are there like. My yeah, since you go to there is a lot of with my name like our name. Website energy or entertaining they can give you right. All those papers they are there. Like especially the printed rainfall. That is what we can call it. I will tell you actually what are those papers. I think now next the papers are there. I'll show the papers. Next slide presentation. I will take my email ID that is Reddy Oh, is it the next sir? It is in final, it's done already. So very good. Nice. So you're working here in the okay. Oh, okay.
It's not done. Sometimes
You can now make the type of oh, let me tell you. Yeah, that's really nice. I think you can see now it's like a on our program. There's some of this. I've worked
आता
yes, sir. Water bodies What the client is that so now what is the you have already that satellite data is there different market point where they are available to on the pixel will be there, right? So that pixel brightness value. So that pixel brightness that is you are already using satellite, you know that is okay. Spectral value. Okay, spectral value you'll get right like different days. So then this what are the exact values, real values? Then we can make a correlation. Regression I should write. So one regression map here. So like what is the value? This is like how much layer are getting. So then we can generate one regression equation. You're getting right. So one regression equation with the spectral, we see the spectral values. Okay. So one is the spectral values. Okay. So what we can do is we can say so by sample is same point, right? One parameter plane over the like 10 days or something that you can again. You may take 1 year analysis, right? 1 year is 10 days or 20 minutes in here. On the time, same thing, but only thing is same time center is not here. Value create something whatever the things like one like that. And what is this value parameter? And what is the whatever you set like the pixel value. So what is the parameter? So if you are gone, making this they are all falling at different places, right? So there are two values in there, right? So means we can make a type of regression equation, right? Means what? So now we are supposed to we can format which make so you have to know that correct. So then I will take 3 black it so I can take the 5 minutes before. So within 5 minutes we can start. Yeah. So like this regression you can make right. That's the issue. So now once later, once we are getting right, it's the pixel value, right? Then each parameter you are getting. So you can easily AI machine learning start to make back to this class. So once this equation you are done, right? Now later what you think your known values you are not fixing the stuff, right? So later what you will get from sampling you want to find out, right? Later only we have spectral signature, then you could also tell that this using like optical back to values, or whatever the other parameters means so you are able to fix here some other location is there. Their own spectral signature is there, you can able to find them. That's why you can correlation is one of the things. Okay, and A initial values dealing with known points and unknown values. Two sets of values, right? They're all prediction. But then you can okay, this talking strategy. Sometimes are available. What we say is you can see it. And that's all. What I'm saying, this is because you can see. From there, you can, with that one, you can develop your own logic connection. Learning your own algorithm, developing. There's a lot of reality. It's one of the areas people are working. Purity and the